Hi, I'm doing example number 3, and if you notice, this one's a little different. Rather than have f of x equals x cubed, this is f of y equals y cubed, and you have the y-axis. So what it means basically, if I were to draw this, I better make sure I did this, because my guess is I forgot. It means if I have a graph that is looking like this, my rectangles, if I have, would look something like this. Okay, and I'm just drawing one right here. And so now this width right here is delta y. And this, rather than f of x, or f of c sub I, is going to be, it's still going to be f of c sub y, but it's going to be in terms of y. Okay, so this will be f of c sub I still, this length, and right here this is delta y. So it's going to look like this. I'm going to still figure out delta y, and it's going to be 1 minus 0. Notice I'm using, these are my a and my b. Here's 0 right here. Here's 1 right here. Over n, and I'm going to get 1 over n. And then c sub I is going to be 0 plus 1 over n times I, or which is simply I over n. And then I'm going to start the limit process again. The limit as n goes to infinity of the summation of a whole bunch of rectangles, an infinite number of them. And I'm going to put in I over n, and I'm going to cube it. Here's my function. And I'm multiplying by my delta y. And so I have got the limit as n goes to infinity, summation of I equals 1 to n. Well, I to the third power is going to be I cubed. And then I'm going to have n cubed, but then I'm multiplying by 1 over n, so this is going to be n to the fourth. So now my limit is going to look like this. I equals 1 to n. And over here I'm going to have 1 over n to the fourth. So really, once you start computing it, doesn't look much different than if it was in terms of f of x. And now I'm going to get rid of the summation. And so the methodology is exactly the same. And let's see, I'm going to have n times n plus 1 times, oops, I think I'm doing the wrong one. I believe I started talking before I started thinking. And it's going to be n squared times n plus 1 squared over 4. There I go. And that's going to give me the limit as n goes to infinity of n plus 1, that quantity squared over 4n squared, which is going to give me the limit as n goes to infinity of n squared plus 2n plus 1 over 4n squared. My leading coefficient here is 1, and so I get an area of 1/4 right there.